Hello everyone. This is a problem in which a small collar of mass small m equal to 100 grams slides over the surface of a horizontal circular rod. The rod is circular. The radius is given 0.3 meters. Also there is friction between the rod and the collar. Friction coefficient is given. We have to find the angle made with the vertical by the forces applied by the rod on the collar when the speed of the collar is given. So what will be the forces by the rod on the collar? In this situation, there will be a normal reaction by the rod, and the normal reaction won't be vertical. The normal reaction would have been vertical if the collar was just resting on the circular rod. But since the collar is moving in a circular motion along the rod, the normal reaction will have two components. One along the vertical and another component will be towards the center, and this component will be responsible for the required centripetal force for the collar to go in a circle. So if we draw the free body diagram of the collar, let's draw the ring first. This is the ring, let us say, and let's say this is the collar. The collar is small, so we can neglect the dimensions of the collar. So the collar will experience one component of normal reaction in the vertical direction. Let us call this NV. Another component in the horizontal direction directed towards the center. Let's call it NH. If the velocity of the collar is towards left, let us say this is B, then the friction force by the rod on the collar will be acting towards left, F. Now NB will balance the weight of the collar. The weight of the collar is mg. So from there we can write our first equation. NB will be equal to mg, and if we put in the values, mass is given 0.1 kilogram, and let us take the value of g as 10. So NB will come out to be 1 Newton. NH is responsible for the centripetal force, and NH in this case will be mv square by r. So let's put in the values. 0.1 and speed is given, that is 2 meter per second. The square of 2 will be 4, and divided by radius is 0.3. So this comes out to be equal to 4 by 3 Newton. So the resultant normal reaction, which can be written as NV square plus NH square under root, this comes out to be under root 1 plus 16 by 9, which on solving will give us under root 25 by 9, which is 5 by 3 Newton. Also, the friction force can be given by mu into n, where n is the total normal reaction, and mu is given. Mu is 0.8, and normal reaction we have already calculated, that is 5 by 3. So this comes out to be 4 by 3 Newton. Now the resultant force on the collar will be the resultant of this normal reaction and the friction. So resultant force on collar by rod, let us call it capital R, will be the resultant of N and F. So this comes out to be under root of 25 by 9 plus 16 by 9, which on solving will give us under root 41 by 3 Newton. And if the angle made with the vertical by this resultant contact force is theta, then let us say friction. In fact, the forces are acting like this. One, NV is in this direction, NH is in this direction, and friction is acting in this direction. So we can say that if theta is the angle that the resultant of these forces makes with the vertical, then of course cos theta we can write as a vertical angle will be due to NV only, and upon then we should take the result all the forces. So NV it is 1, and upon resultant of all the forces is under root 41 by 3, which can be written as 3 upon under root of 41. And so theta comes out to be cos inverse 3 upon under root 41, where theta is the angle that resultant of all contact forces makes with the vertical. I hope it is clear. You can go through the solution once. Thank you very much.